In this video, we review the International System of Units, commonly known as the metric system. The metric system is widely used around the world. Parenthetically, SI stands for the French words Système International. The metric system is entirely constructed from the 7 base units shown here. In our discussions, we will be using the meter, a measure of length, the kilogram, a measure of mass, the second, a measure of time, the ampere, a measure of electrical current, and the Kelvin scale, a measure of temperature. Actually, we'll use the Celsius scale, which is a more accessible version of the Kelvin scale. Some commonly used metric measures derived from base measures are defined in this table. We will be using the square meter, a measure of area, the cubic meter, a measure of volume, and meters per second, a measure of speed. This table defines other less frequently used metric measures. We will regularly use these measures shown here in orange, including the joule for energy, the watt for power, the volt for electric potential, and the Celsius temperature scale, a useful version of the Kelvin scale. We will make occasional use of other measures as shown here in blue. This busy graphic shows many other metric measures that derive from metric base units. Some of them are quite arcane. The point of showing you this graphic is simply to illustrate that the metric system is both consistent, meaning not arbitrary, and coherent, meaning all measures are logically connected and defined. Compare this to the old English system of measures that you may know, with its multiple measures for length such as the mile, furlong, fathom, rod, chain, league, and many others, and its measures of volume such as the dram, gill, pint, pottle, gallon, bushel, and peck. Another reason for using the metric system is shown on this map. Every country in the world, save 3, now use the metric system. Only the United States, Myanmar, and Liberia hang on to the old imperial system of measures. For those of us stuck with the imperial system, here are some useful quick conversion heuristics. A meter is a bit more than a yard. A kilometer is a bit more than half a mile. A kilogram is a bit more than 2 seconds, or 2 pounds rather. A metric ton is about 1,000 kilograms, 10% more than a U.S. ton. A square meter is 20% more than a square yard. A hectare is a unit of land area defined as 10,000 square meters, which is about 2.5 acres. And to convert Celsius temperature to Fahrenheit, the exact formula is F equals 32 plus 1.8 C. A quick and dirty approximation, easy to do mentally, is Fahrenheit is equal to 30 plus about 2C, which works pretty well for temperatures between 0 and 100 degrees Fahrenheit. Try it out. This table shows prefixes for orders of magnitude. Commonly used prefixes are giga for billions, as in gigawatts, not gigawatts as is used in some movies, mega for millions, as in megawatts, kilo for thousands, as in kilowatts, milli for thousandths, as in millimeters, micro for millions, as in micrometers, and nano for billions, as in nanometers. But the table also shows that these terms are not consistent and vary between short and long versions. What's going on? This map illustrates that terms for magnitudes vary around the world with little consistency. The dark blue and medium blue countries use the short scale, but medium blue countries use the term milliards instead of billions. The light green countries use the long scale, and the orange Asian countries use different terms altogether. These differences can lead to much confusion when communicating across borders, so be careful. To confuse matters even more, there is variation regarding how thousands and decimals are represented in written numbers. The blue countries separate thousands with a comma and separate whole numbers from decimals with a period. The green countries reverse this, separating thousands with a period and decimals with a comma. The red countries use different systems altogether. In summary, the SI metric system is an almost universal system of measurement that is coherent and consistent. Base units that are relevant for us and will be frequently used in future videos are meters for length, kilograms for mass, seconds for time, amperes for electric current, Celsius degrees for temperature, and all other measures that we use will derive from these base units. When representing numbers, we'll use the short magnitude scale in which a billion equals 10 to the 9th power, and we'll denote thousands with a comma and decimals with a period. When I'm king of the world, I'll get all this straightened out, but until then we're stuck with some notational confusion. Sorry about that. In the next video, we will continue our discussion of measurement with a survey of practical ways that energy is measured.